determine the sample space associated with this experiment. So look at this thing here. I have the dice that have 12-sided. What are the possible outcome? What are the total possible outcome for this 12-sided dice, right? Which is hopefully you say, well, if we have 12-sided dice, then there should be 12 possible outcome, which is one side contain number 1, one side contain number 2, one side contain number 3, and so on and so forth, right? So there are 12 sides, the sample space will be 12 of them, right? And B, they ask you, determine the outcome associated with the event E if the toss, if event E is equal to the toss number less than 6, right? The number that we want to choose have to be smaller than 6. So what are the possible outcome of the number smaller than 6? So to find this thing here, do you agree that the number smaller than 6 is 1, 2, 3, 4, 5 here? 6 is not smaller than 6, so we cannot choose 6 here, which is everybody see that again, it's 5-sided, not 6. Okay, so again, apology for the typo, right? There's only 5 side. There's only 5 side that is less than 6, which is 1, 2, 3, 4, and 5. Okay. So looking at this thing here, which is again, we know that this is a specific outcome we're looking for, and we know that the part A is the total outcome that we have. And now they actually find the probability of you select or you roll the dice and the dice land on the number less than 6, which is again, what is the probability? The probability will be you have 5 items smaller than 6 out of the total of 12 items. Right, which is again 5 out of 12, which is that will be your answer. Unless Alex asks you for decimal, you can divide them and give them the decimal. If not, just give them 5 over 12 because this is your lowest tone. You cannot reduce this item. So now they ask you, suppose that you have this thing here. Suppose that you are given the number is even. Again, what is the word given mean? Hopefully you guys remember that they say, well, given meaning now there are some condition have to occur. And reminder that when we went over this, I told you that anything after the word given is your new probability, right? So look at this thing here. Suppose that you are given the number word even, meaning now we take just the even number out, right? We just take the even number out. What does the new sample space look like? Well, the new sample space should be, do you agree that this is what we have, which is again, we have 6 sides on this 12-sided dice. I have 6 sides, which is 2, 4, 6, 8, 10, and 12. Those are my even number, right? This is what they tell you is throw away all your odd number. We just need an even from this sample space, which is this is my even item for my sample space, right? Now they ask you determine the outcome associated with a number less than 6 given the number is even, meaning now we are no longer, ladies and gentlemen, we are no longer look at this 12th item here. This 12th item is gone. We only look at this 6th item, right? And again, they ask you with this 6th item, basically again, given this 6th item here, which of them are less than 6, which is, do you agree that 2 and 4, those are the number that is less than 6, right? So my sample space that associated with this thing here is, I only have, again, sorry for the typo, it's only 2 sides, right? It's only 2 sides, which is number 2 and number 4 here, right? So looking at this thing here, number 2 and number 4, which is those are the 2 sides that are even, right? Or those are the side that who are number less than 6 and also that are even, right? And again, looking at this thing here, lastly, they ask you find the probability, right? This item here, find the probability of number that is less than 6 given the number is even. Meaning again, remember I told you guys that we have this vertical line, and if we have this vertical line, I told you guys that anything after the word given is your new total. Which is in this case, how many total, how many number that are even, which is hopefully you guys say that there are 6 even number, and out of that 6 even number, there are 2 of them are number less than 6, which is 1 out of 3, right? 2 over 6 you reduce to 1 out of 3, or if you give them the decimal 0.333333. Okay, so again, this is basically, hopefully you guys see that this, the conditional probability is when you see the word given, those are your conditional probability. And those are the items that you want to, those are the keyword that you try to looking for, okay? So question with this item here from A to F in terms of this item, they kind of slowly lead you to the answer. They slowly ask you the question so that it lead you to the answer is that way. All right. Let's attack another probability problem. And hopefully this probability problem, you say, well, this, Mr. Tran, this is an easy, simple probability problem, right? So the first one here they ask you is, again, given this bag contains 3 red ball, 4 blue, and 6 yellow ball. A ball is selected at random. A ball, meaning 1 ball select at random, and the color is noted. Find the probability that you select a red ball. Which is, looking at this thing here, everybody see that this is just a simple probability. What it means simple probability, meaning we only select one item, and what's the probability of just this particular item, right? So looking at this thing here, hopefully you can say, well, how do we find this probability? Which is, again, how many red ball do we have over the total of ball that we have, which is, in this case, everybody see that we have 3 red ball over 13 total, which is, again, 3 plus 4 is 7, 7 plus 6 is 13, which is, in this bag we have 13 ball and 3 of them are red, which is the probability of get a red ball is 3 out of 13. And if you read the second question, hopefully you guys say, oh, Mr. Tran, you guys been leading me to this point here, which is, again, hopefully you guys see that this is the keyword, which is, again, find the probability of select a red ball given the ball selected were not blue, right? So looking at this thing here, because of the word given, we know that there is a conditional probability, which is the conditional probability. We no longer look at 13 total item, right? We look at this thing here, which is, again, looking at this item here, how many items are not blue? Which is, again, everybody see that we have 3 red. Everybody see that we have 3 red here, right? We have 3 red and 6 yellow, which is, everybody see that there are 9 items are not blue. So out of that 9 items, how many of them are red? Which is, everybody see the probability is 3 out of 9. We have 3 out of 9, which is, again, 1/3, right? Because of the word given, we need to extract those items out, which is, again, there are 9 items that is not blue. Out of that 9 items, there are 3 of them are red. Right? So those are your conditional probability. And now number 17, this is, I think, one of the question, or some of you guys sent me this question earlier and we went over this on Alex. But again, when you attack this problem, I told you guys that with this problem here, Alex does not break it down in terms of this material for you, or in terms of step A, step B, step C, like I did in the lecture we have earlier. But again, this thing here, they say 4 students, A, B, C, and D, are given a speech to the class. The order of speaking is determined by randomly selected, right, or randomly selected. And again, find the probability. They go straight to find the probability that the C speaker will speak first, right? So look at this thing here. Before we can find a probability, if you remember, before we can find a probability, we have to find a total of ways that we can do this, right? Which is, looking at this thing here, because that there are some order, everybody see that because there are some order, we have, or in terms of this thing here, this is a permutation problem, right? Because the speaker have to go in order that we want, which is because there's some order is involved. We know that there's a permutation quotient, or is basically 4 factorial, right? which is again, looking at this thing here, 4P4, which is again 4P